Up next, we're pleased to announce Arun Seagal. Arun is a worldwide business development leader in the Energy and Utilities Business Unit. In his role, Arun works with utilities, software vendors, and global system integrators who are building solutions for their business needs on AWS and helps drive digitalization transformation of utilities around the world. Prior to his role, he has over 27 years' experience in smart metering, smart grid, and IoT industries around the world.
Didn't expect to hear that much, but good morning, everyone. Anybody paying attention to the fall equinox today? Who woke up early to see the sunshine? Anybody? Everybody enjoyed the evening yesterday too much, I guess? So good morning, everyone. My name is Arun, as was mentioned earlier. I'm here to talk to you a little bit about how AWS is becoming a key anchor to the digital transformation of utilities around the world. We are all, as Neil mentioned very eloquently before my presentation today, that the industry trends are clearly towards decarbonization of the industry, the decentralization of the energy resources, and just general digitalization impacts happening throughout the world. We are all wanting to become more and more interactive with technology, and I think the use of technology to balance the grid is going to become more and more important as we go further. Whether it's the electrification of the supply, of the demand, especially now with the transportation. I was in a conversation recently with a utility where they're expecting 15% increase in their sale of kilowatt hours just with the advent of electric vehicles, which has never really happened for the longest time. We all know that utilities have had a flatter demand, actually reduction in demand in many cases, and reduction in the electrons they could sell. So this is becoming a really interesting element in their business. The distribution of energy resources. Markets like California are coming close to 15% of homes getting solar or distributed energy resources. But globally, some markets are even more entrenched in distributed energy resources than the North American market. Look at Australia, for example. State of Queensland has got almost 50% homes which have got a solar rooftop or distributed generation. And the impact on the grid passes the inflection point once you are at about 15% or so. What you need for balancing of the grid, what you need for grid stability, suddenly becomes an enormous amount of work than what it was when you had more centralized generation. And last but not the least, the impact of aging workforce, the impact of younger people wanting to come and run technology in a very different way is all impacting how grid stability will be viewed in the next few years. So flexible generation, situation of flexible delivery. We have never really grown into a place where a load worth a house could be moving around from one distribution transformer to another distribution transformer 7 times in a day. Just think of it this way, right? If a Tesla was moving around and getting itself plugged in different locations, you literally have a load of a house moving from one place to another. So that mobile workload, that load, has not been into our business planning, into our electrical grid planning for the longest time. And suddenly that is going to become an important part. So not only just the generation, but also the load itself has become mobile and needs to be looked into. All this is impacting how we are looking at our grid. How are we managing the grid stability? We were in a conversation with a large utility on the East Coast recently where they were talking about doing power flow analysis once every week. And they said state estimation is done whenever state estimation is done. And the discussion came that what if you could actually do a power flow every 5 minutes? How will that grid behavior change? Could you achieve much more stability? What can you change? Can your DLR ratings change if you could actually go out and do this every 5 minutes? Which means the kind of compute you require, the kind of storage you require, the kind of a memory you require to go do these things is suddenly going to change, right? And you cannot build data centers fast enough to be able to go harness the power of that ability you require to go actually and make those calculations, make those applications work to deliver you the value what you need. So I open up the topic here of what is cloud computing. Everybody here has used cloud? The answer should be yes, you have. Yes. At least for your Gmails, right? If nothing else. So cloud actually, the reason I bring that up is cloud is probably the closest to our utility business than anything other. It's a pay-as-you-go business, right? So if you use a compute or a storage or a memory, for 5 minutes, you only pay for 5 minutes. That's what a public cloud is. So it is really using of these resources for as long as you use them, you pay for only that, and then you don't pay for it. So instead of buying $1 million data center or a $10 million data center, if you're only going to use it for 2 hours in a day, you can literally run those applications on public cloud and just pay for 2 hours. And that is what the beauty of a public cloud environment is. So from a business perspective, it is very similar to what you do, right? If you turn on the lights, you pay. When you switch off the light, you don't pay. You turn on the water, you pay. When you stop the water, you don't pay. And that is exactly what cloud computing does for you. It normalizes the use of computing technologies for your businesses only when you need it. How many of you have used a meter data management solution? A few hands, right? We all run validation, editing, estimation in those solutions, right? Many of our customers run it for 6 hours. We all know that that is a compute-intensive part of your business at that time. What if you could only buy compute for those 6 hours? What if you could run those only in 5 minutes? How does that change your business? Those are the kind of topics which I want to explore today with this team. And also, the topic of what cloud brings to you in terms of resilience. It is a place which is far more secure, is probably far more available than your own data center will ever be. And we'll talk about that in detail. So what does Amazon Web Services offer? We offer, of course, everything what a traditional data center offers, and your ability to run these, as I mentioned, on demand, as and when you need it, to the scale when you need it. To give you an example of the advantage of scale, how many of us have deployed smart meters here? Many of you probably would have noticed that when a big storm passes and all these meters are sending you outage messages, many of you are ending up turning off your OMSs because you don't want all those hundreds of thousands of messages to come swamp your OMS. What if you could get those messages? What if you could ultimately scale up your OMS to run for that 35 minutes of outage, get all the messages, and then turn it off without spending more than $100 on a compute or a resource? Not needing to actually build a data center to go do these things. That's what the power of cloud is, and that's what cloud brings for your day-to-day use of your applications. So how are we touching utilities? We work with utilities which are decarbonizing, which are working towards decentralization of the energy resources, and we work with them on these 6 primary areas. We work with the utilities on the IT transformation needs. If you are looking at running your business applications, your IT applications like SAP, your Oracle, your IBM Maximo, you name it, right? Those applications, if you're running for your billing systems, for your other IT systems, you can run them far more efficiently at far less cost when you're running them on a public cloud. So that's a transformational role which is happening in utilities around the world. One thing which is pretty interesting to note here is that if you run an application in your data center, and if you run that same application on AWS, your carbon footprint for that particular application drops by 90%, which tells you how much more efficient we are in terms of our use of our compute resources. So those utilities and the leadership of those utilities who are looking to really show an impact that they are paying attention to their carbon footprint are also looking at cloud as one of the mechanisms, not the only mechanisms, but one of the mechanisms of reducing their carbon footprint. IT transformation is something which we are here to talk about. I want to thank the Minsait team here for inviting us here. I want to thank my friend up there, Jorge, whom I'm going to bring up on the stage very shortly to talk about the experiences they have brought on the operational technology transformation. But we are working with utilities around the world to do things like load forecasting, ability to forecast not only long-term, but next 5 minutes. What is going to be a consumption? What is going to be a generation over the next 5 minutes, or especially if you're distributed generation? We are bringing together the weather data and the consumption data and the generation data from all these sources and doing near real-time forecasting for utilities as and when they need it. We're working with them to develop digital twins of their whole grid, of their substations, of their power plants, and see how much efficiencies they can achieve out of understanding, doing predictive maintenance, predicting which particular gear of your wind turbine is going to fail first, and actually ship the product before it actually fails. So working to develop those kind of solutions which are really impacting your day-to-day operations and helping you improve your performance indices. We are working with utilities also to understand and better manage their assets, whether it's their distribution assets, whether it's poles, transformers, you name it, or whether it's their people's assets. How are you better managing them? How are you routing your workforce better? How are you managing in case of a storm coming where the equipment will be placed? All these technologies are now using the power of cloud and power of AWS to offer you the most accurate information in the fastest possible time. We're working very closely with ISOs, for example, to do much better job on planning and simulation. New England ISO has recently published a lot of documentation on how they are using cloud for better understanding of the grid stability which they need. Really encourage you guys to look at that, of the work they're doing in this field. Customer engagement remains central to us. We came out of Amazon. It is the central theme for us. So we work very closely with our utilities to offer them born-in cloud call centers, which are cloud native and are extremely extensible whenever you need them. During COVID times, a lot of utilities went into this issue where they got a lot more customer calls to prevent disconnection or non-payment of bills. And they were able to expand their call center almost effortlessly by using the power of Amazon Connect. We work with utilities to develop customer 360 views. So even when the phone rings, the CSR already knows why this customer is likely calling and is already prepared for that. So really having a predictive view of why a customer is calling. Better understanding customer sentiment analysis. Is the customer not happy with our performance? What can we do to improve that? All that comes as part of our experiences, which we are sharing with utilities around the world in the area of customer engagement. And last but not the least, I want to touch on ESG. Many regulatory environments around the world are now beginning to ask utilities to also report on the ESG. And one of the first things they need to do is better understand how to actually measure and report on their carbon footprint and carbon tracking. And we are now providing utilities with tools to better offer that information in a common standardized way. So these are all the applications which various of our partners are developing on the tool sets which AWS is providing to our partners and our customers. None of this will be possible without achieving resilience and compliance in the cloud and security in the cloud. Security is day zero for us, is the first activity we all do. We spend an enormous amount of money in maintaining and establishing security practices. And we are also very active in the NERC community. My friend here, Ranjan, he spends enormous amount of time in testifying in front of work committees and also attending the NERC sessions in where they are rewriting the standards to better understand how they can use cloud and the adoption of cloud. Many of you may have also paid attention to this announcement which came out late last year about bringing the BCSI workloads into the cloud, BCSI data into the cloud. So NERC now explicitly allows you to bring the data for all sorts of analytic purposes which you couldn't do in the past. We are very firmly working with the NERC community to better develop standards which can be used to improve the situation of how cloud can be adopted for better management of the grid. So you can use this BCSI workload to, of course, store your data, but also do far more predictive maintenance than you could ever do in the past. I'm working with utilities where they're bringing even visual data to cloud. So many of you are probably using drones or other mechanisms to gather imaging. And now they're using machine learning to better understand whether the sag on the line is still proper or not, or whether a transformer is getting eroded or not, all by looking at the imaging and running AI and ML technologies, artificial intelligence and machine learning technologies on these imaging to better understand what is happening on the grid. So while many of you are gathering imaging, you can understand what to do with those images much better by bringing them to cloud and managing and running AI ML visual analytics on top of those. And last but not the least, we are also looking at even the physical security aspect of it. There are now utilities who are looking at, for example, visual analytics on whether the person is wearing the right equipment or the right gear before walking into a substation or walking into a hard hat areas. And you can detect that just by having the cameras run visual analytics of what is coming. So all those capabilities are now available to make you much better secure and more, and being able to offer high safety standards for your teams as well. So these are just few of the use cases you can see, which I talk about here, of how use of cloud is changing the day-to-day operations of utilities around the world. I mentioned to you about NERC. I think I'm going to skip in interest of time here. I've got 1.5 minutes before I call my friend up here. I think I'm going to share these slides with you, but key thing here is to look at the revisions in SIP 4 and SIP 11, especially, all around BCSI workloads. So if you're handling BCSI data, this is the time for you to start looking at how cloud can certainly bring value to their data for you all. I want to leave here with a couple of examples and talk about how energy transition is happening and how cloud is the place where resilience is happening for utilities. We've now had several conversations, even with many of the water utilities, to look at, can they run their mission-critical workloads on cloud? What if running a SCADA on cloud, right? Can we run, what kind of a controls should we look at which we can offer on the cloud? Or at least, can we bring technologies like outage management system on cloud? How can we better understand the data coming out of a SCADA, data coming out of our OSI Pi, better coming out of our Maximo, and see what value proposition exists for them to start using the data much more effectively than they have done in the past. I've given here a few examples. Octopus Energy probably is on the retail side. They grew out of a very small operations in UK, and now they are one of the largest retailers in the world. And they are pretty much running utility on a box, everything on the cloud. All their operations are running completely on AWS. That includes customer retention, that includes customer billing, that includes signing up of the new customers, managing their complaints, if any, giving them newer, interesting rates to look at, offering special green electrons rate versus EV charging rates, and so on. All of that is being managed on AWS. Engie worldwide is using asset prediction using AI ML technologies with AWS. This is going to be one of the largest use cases as we all look at how do we control our OpEx and better utilize the funding to better manage our equipment. Anybody who is running, for example, a fossil-based power plant, they're all looking at reduced funding for them to manage their power plants, but this still are required to keep the lights on. And how do you better understand where to spend your dollar? Using AI ML techniques on cloud can help you better position yourself in figuring out what equipment is likely to fail first and where can you go have a meaningful impact. And you don't have to invest in expensive technologies in the plant to go retrofit to take advantage of that. We've had a lot of interesting innovations with utilities on this. I'll give you just 2 examples. In one of the conversations with a power plant, the staff was telling us that, oh, I can just hear the vibration of this motor and tell you whether the bearing is going bad or not. And we all picked up on that and said, what if we could just put some vibration sensors and just listen to it and run an AI ML algorithm on top of it to figure out which machines are going to get impacted first or have their bearing run down. And with literally like spending $24 per machine, they were able to put these little sensors on top of it and bring analytics back up, instead of trying to rewire it or do something different to understand what's happening. We are working with interesting companies which are putting thermal imaging, for example, in their substation and the equipment, and they're just looking at imaging and then analyzing whether something is overheating or not. So there are newer, innovative ways to look at the data and going back and doing predictive analytics much more easier than what you could have done in the past. And you can bring all this data and actually really make good value of all sorts of data, not just a structured data, but any sort of data can be brought value out of. Just some of our customers, I just want to name a few here. We are working with utilities around the world. Many of these names will look familiar to you. We are working with technology partners around the world. Happy to share more details about any one of these at all times. And at this stage, I want to bring my good friend Jorge, who talked about this yesterday, but how they are running their mission-critical system of SCADA to run on AWS. So please welcome Jorge.
Thank you. Hey, good morning. How are you? Thank you for the invitation, and to Ron, thank you for everything. My name is Jorge. I come from Guatemala. I'm the IT manager of a distribution company in Guatemala. I'm going to give you some information about my experience working in a project. This is not a commercial. I'm not a salesman from AWS, neither ACS. I'm just a IT guy that really likes to do changes. So I work for Energuate. This is a major distribution company in Guatemala. We serve 2.2 million homes back in Guatemala. And we are the energy that moves Guatemala. That's it. That's our slogan, and it's very true. And some facts about us. Like I said, 2.2 million customers. We cover almost the 93% of the territory of Guatemala. We have more than 13,000 collection points covering all the territory, all the place in Guatemala. We have 1,000 kilometers of network. So we are a really big distribution company. We are the major distribution company in Guatemala. So we have an idea. Since 2014, we are using the Prism SCADA from ACS. So we are evolving. Energuate started an evolution process 10 years ago. And maybe a couple of months ago, we started to think about how to make the next step. So working with ACS about the update of our version on SCADA, we realized that we can go to the next version. You saw the system this morning. It's a web-based system. And we had a lot of problems due to the pandemic. So our the control center back in Guatemala was centralized, and we need to decentralize it. I am very sure that you faced these kind of problems in the past. So we think about the cloud and what we can get from the cloud. So we faced that the IT costs are increasing every year, and the infrastructure are underused. So we realized that we can take the advantage that we have in AWS with a cloud, not specific with the AWS, but with the cloud. And we started to look how to realize this process, how to make this process real, this project real, I'm sorry. Another very important issue for us was the disaster recovery system. We didn't have a disaster recovery system because our SCADA version was on-premise and only has 2 nodes. It only has a high availability, but not redundancy. So we started to think about how to resolve this problem. So we started to think, we started to work with ACS, and we started work with AWS directly. Yeah, they worked from the beginning, and we designed this architecture. So we are going to have, we're thinking in have 2 nodes in the cloud, and we have a 3rd node in our data center on premise. Yeah, why we did that, or why did we choose that architecture? Because if something happened with the cloud, because the things happen, yeah, not only the problems or something that is out of our control, but the maintenance, the normal maintenance. So I'm sorry, but AWS is not always online. So we need to have the 3rd node in our data center. So we are going to have a very really reliable architecture with high availability. We are looking for 99.99% of availability. So this is what we choose to do. And it's a very complex. Yeah, the challenges that we faced, that I'm going to explain it later in the presentation, were really challenging. Yeah. So I learned a lot in this project. So I'm going to share with you a little things. So one of the most important things that we worked on was the communication. You know that this kind of system needs real-time communication. Yeah. With low latency communication. So we decided to use the direct connect. So we have a data link from our data center to the data center in Virginia. So we have a very low latency, yeah, less than 20 milliseconds from the remote RTUs to the data center in the cloud. So that was an issue that we need to be solved in that time. Now we are facing a new challenge because the VPN technology that is probably the most backup system used right now, it has a lot, the latency is too much. So now we are realizing that we need to have 2 direct connects. We will have to have 2 data links between our data center and the clouds with 2 different ISPs in order to have the redundancy that we need and the low latency that is required by this kind of system. And this is why we choose AWS. Yeah. The most important here is the security of the system, because the SCADA will control all the assets in the network of Guatemala. Yeah. So we choose AWS, and we use security by design. All the solution was designed thinking about the security. So we started with the securities, starting with the operating system. All the information to the channels using the direct connect are encrypted. So all the information is really secure. And these are the challenges that we face when we trying to do innovation. Yeah, I try to think about myself that I really like to be in trouble, because I didn't have the need to be uploading this kind of system to the cloud. But not only face the resistance to change. Yeah, because this always happens in this kind of project. When you do major changes, we face the resistance to change. We face, when we design the architecture of the system or the requirements for the system, then we need to move that requirement or make it real on the cloud. So we need to choose the right machine. We need to choose, or we need, something that we worked on was the IOPS, for example. We need to choose the exact number of IOPS for maintain the cost of the infrastructure and the system working. So that kind of thing. So it was a very long project. I'm seeing the light by the end of the tunnel right now because we almost finished the project. Yeah, maybe we are going to finish it by this December. We're going to go live with the system in January. Right now we are going to start the point-to-point testing. But we have a very good team. This was a really teamwork, not only by the engineers of AWS, by the engineers of ACS, by the engineers of Energuate. Also, we have the support of local partners in Guatemala, experts in AWS architecture, experts in AWS security. So we assembled a really good team at the Avenger, yeah? And we talked about, we talked so much about the budget, yeah, because maybe you are thinking, this is expensive. It's better to make investment in new hardware, new servers, or translate that to the operation expenditures and have a cost-effective architecture. So it really is, yeah, it really works. But you need to do it really paying attention to the details because that's really, it was a really important thing. So we designed a cost-effective architecture and make it real. And AWS is capable to do that. Another challenge was keep the project on the budget because when the times increases, of course, increase the cost. But in our case, that didn't happen. We maintained the budget stabilized. It was exactly what we designed. I'm sorry, but I'm really rusty with my English, so I hope you are understanding what I'm saying. So this happened because we have a lot of experience from AWS, from our partners. So this could be done, and we prioritize the function of the system. The easy way out of this project will have been stay on premise, and in some steps of the project, we talk about that. Leave it. No more project, no more AWS, no more. Yeah, it was a really hard meetings. I had really hard meetings, really frustrating meetings, but with the object in mind, with the objectives in mind, with the goals in mind, I think we did a really good job with the team. So we have a very good project manager. As a matter of fact, we have two project managers, one here in the United States and the other one in Spain. And we have a really, really good support. So what do we wait from this project? First of all, we need to improve the availability, the performance and the availability of the, and this is going to impact the KPIs about time and frequency of the failures, of the interruption. So we need to reduce that. We need to increase the operation and the velocity or time of response of having the system online, having the network online. This will be impact directly of the quality of service for our customers. And now, as Arun says, we have a very flexible architecture. When we need more performance, we can have more performance, and that is really easy to do. And we are going to maintain the investment where are needed. And now I'm thinking about move all my recovery system through the cloud, because if this kind of system can work on the cloud, I think any cloud, any kind of system could do it. So if you need know more about the project, of course, you can reach me, and maybe my contact is over there, and you're going to have the presentation. But let me tell you that these kind of things can happen. I'm really too happy to share this small part of the project with you, and for the invitation. I'm really honored because Arun gave me some space in his presentation. But I'm really happy to do this. I'm really happy that the project will be live in a couple of weeks, and has been really hard months in the past, but this can be done. So I can share our experience. If you are trying to do this kind of project, you can talk to me. I can share my experience with you. And until yesterday, I believed that we are the first one doing this. My friend here says that there are another company in New Zealand. So, yeah. So, thank you so much. We have now I have a really good motivation to go live as the first one moving the SCADA to the cloud. So, thank you very much for your time. Thank you.
Thank you, Jorge. Thank you.
You have any questions?
Any questions?
How long did it take to get? I think I missed this time. When did you start the process?
We started the process by the end of 2020, almost 2 years working this project.
Just 2 years?
Yes, almost 2 years. And this is the one thing that I forgot to mention, that we did all this through the pandemic. Virtually, remotely, everyone working from our homes. So that's another thing to think about. Maybe, yeah, this was the first time. So we have to pay attention to the details, really details. We have a really hard meetings, because we had to figure out how to solve things. Basically because we need to system working and the budget working too. So that's why we took a lot of time. Yeah, in sometimes, like I told you, for us will be better leave it that way, or let's buy the infrastructure and leave it in our data center. But we have a goal. Okay, thank you so much for your time. Thank you, Arun.
Thank you. Thank you again.
Hello everyone. I'd like to say now we have a break, and first of all, I would like to thank Arun and Jorge for this great presentation, for this experience. Now we have a break, and then you can have more information on SCADA in the cloud, on edge computing, on innovation and distribution. We have a panel with AWS, with our friend from Avangrid, Jorge Chapero. We have Santiago Cascante from Grispertise, and Miguel Asensio from Minsait. It's going to be a 4-people panel. They're going to present each one their experience, and we have a number of questions for them to get deeper into how a roadmap to ADMS and edge computing and DERMS application through cloud. So we're waiting for you here in 20 minutes, and enjoy the break. Thank you very much again to our guest. Thank you very much.